Hi everyone. Hey, this is Electrolytic Cell. So, yesterday we talked about the voltaic cell and how we saw chemical energy is converted into electrical energy. So, for electrolytic cell, you're looking at the other way around. You're looking at electrical energy or using electrical energy uh, to do chemical work. Okay? So, here's a word here, electrolysis. If you remember, the last time you hear the word electrolysis, you were thinking or you were given this reaction. And somebody would tell you, that's called electrolysis, using electricity to break apart water to give you a H2 and O2. There you go. I think your teacher might have even tested this by lighting a flaming splint and get that little pop like this with a flaming glowing splint to get flame reignition. Well, the idea is kind of sort of the same here, kind of, I guess, but we're not interested in looking at electrolysis of water, not today. Okay, we're looking at a electrolytic cell. So, in order for this reaction to occur, you need a battery. Okay, you need a supply of electricity. You need some sort of electrolyte. Okay, in this case, I'm going to pick lead bromide today. Lead 2 bromide to be specific. So what you need to make sure is that the electrolyte and the electrode that is made out of graphite today, they're not reacting. Okay? So we're going to see how that works. Okay? So I have a blank sheet here, just like last time, and we're going to build today an electrolytic cell. So first, I need a beaker. One beaker today. So that's one beaker. Now let me make this a big beaker. So I need to write a lot of things inside this beaker. Here's a beaker full of electrolyte. And as I said, the electrolyte today is the example lead 2 bromide. All right. I have 2 electrode. And this electrode is graphite. Now, graphite is covalently bonded by a whole bunch of carbon in a very, very tight carbon network. All right? Now, these graphite are connected by wires through a battery. Do you remember that? And do you remember that in this battery, this is the positive end, the shorter end is the negative end, and an electron moves out of the negative end, and an electron moves in through the positive end. Remember that? Don't worry if you don't. It's not a big problem today. All right, so here it is, electrolytic cell. Remember, this reaction is non-spontaneous. This is nothing is going to happen if this is not there. If this is not generating voltages, this reaction stays and nothing is going to occur. Okay? So, this is what's going to occur. Since the battery is in place, an electron is being flown from one end to the other. this is where lead bromide will do its work. Dissociation. Okay. That's what's going to happen. Huh. There should be 2 of them. Okay. It's very important that you put 2 of them together. Why? Because of this. Let me just draw the dots. Let me draw its valence electron. Okay, let me draw those valence electron. So PbBr2 would dissociate to give you 1 Pb and 2 Br. Now, these 2 Br, they don't want to be ions. They actually don't mind coming together to form bromine gas, if you think about it. Okay, I really should, you know what, let me just redraw this. Okay, I really should have bromine over here. Makes more sense because of how I put my battery. Okay, I should have reversed the battery, but then no big deal. Let me just redraw this. So I have 2 bromine here. Okay, they're both negatively charged. They don't want to be negatively charged. They rather be neutral. In order to be neutral, these 2 bromine, they want to come together to form Br2. They do. So what do? Very simple. They say, hey, take this electron and put it here. Take this electron and put it here. Let me just draw that for you. Okay? This electron come over here. This electron come over here. And let these 2 electron bond. Bond. There we go. Hey, now this becomes Br2. Right? The electron over here are going to be used by the battery and gets pumped to the other side of the graphite. Right? Now, what are these electrons going to do? What are these pair of electrons going to do? Now, these pair of electrons will actually go through the battery. And this battery's job is to give them potential. Okay, give them the energy that they need to go to the other side. Once they're on the other side of the graphite, this is where lead come into play. Lead will say, hey, thank you very much for the electron. Okay, both of those electrons, thank you very much. Because now I can become solid lead. Okay? I could become solid lead. Well, not really. It's more still in a solution. You're looking at more like a liquid lead, but very high concentrated lead nonetheless. If you think about this build right here, it's a pretty dangerous build. For sure, I'm not going to ask you to build with molten lead to bromide. Well, first of all, I don't have lead bromide for you to play with. So most likely we're going to use something else. I'm probably going to get you guys to use sodium chloride to build one of these things. So yeah, because if you don't know, this gas is a pretty poisonous gas. People use this to disinfect hot tubs and maybe some small swimming pools because it has bacterial killing ability. This is poisonous to human. Come on, lead. There's a reason why we don't make lead pencil with real lead, else you guys will be dropping left, right, center. So I guess this is exactly how electrolytic cell work. The electrolysis here is breaking apart PBBr2, because PBBr2, they don't break apart spontaneously. In fact, they rarely break apart. Okay, you want to break this apart? Supply some energy, and that's how you would do it. All right, so let's go back and just kind of summarize exactly what we saw. So we have the electrolyte lead to bromide. Because of the electricity being generated here, lead to bromide will break apart to give you 2 bromine and 1 lead. Okay, the bromine will become bromine gas by dropping 2 electrons into the graphite electrode, bonding the other 2 electrons as a covalent bond. These 2 electrons, with the power of the battery, will get pumped into the other side of the graphite electrode. And in the other side, lead pick them up to become liquid lead. All right? This will continue and continue until, of course, the concentration of lead bromide is low enough. Okay, or the battery runs out of power. Now, let's take a look at what's going on here. Okay, so what we saw here on this side, okay, is 2Br minus becoming Br2 and 2 electron. Okay, so we know this is oxidation, but positive or negative? That's right. For a electrolytic cell, okay, this is positive. Okay. Anode. So right here we saw Pb2 plus getting electron from the graphite to become Pb. Okay, obviously a reduction. And that's negative for electrolytic cell for this cathode. Okay. All right. Hopefully you can draw one of these two. I do have 2 examples for you to draw today. So here's the breakdown in terms of electrolytic cell. In this example, I use NaCl, molten NaCl as my electrolyte. And hopefully you can see here that this is the cathode and this is the anode. So this belt right here is a little bit of a reverse, okay, because the electron is actually traveling this way, but it's not anything that you don't understand. Okay, here's the same diagram. Okay, this time the electron is going this way. Okay, I have problem 3 right here. Describe the electrolysis of NaCl. I'm not sure why I gave you this question, because it's basically what you see here, but see if you can not look at what I got and draw your own electrolysis, okay, with graphite being the electrodes. Oh, here's another one that's different, okay, calcium chloride. Okay. Do it again with calcium chloride. Right, hey, that brings us to the end of electrochemistry. We are going to have, I guess, a test on this, okay, sometime later at the end of the week. I'm going to get you guys to do a test on topic 7 and topic 8. All right, so for topic 9, maybe sometime in a couple of weeks, who knows, but that's electrochemistry. So our last topic is organic chemistry. Now that is going to take us around like 3 to 4 weeks to complete. it is a lot of work. So hang in there, guys. All right, that's it for today.